Hi everybody, welcome to Science Chomp. Today we're going to be looking at how to balance equations. Now a couple of things straight away. I'm going to show you two methods, one using pictures and the other one using a more mathematical approach. And well, let's just get right into it. It's probably easier. Okay, so the first thing is let's get the atoms put down. So the first one is H2. That subscript number 2 says there's 2 of those hydrogen atoms connected to each other. Similarly with oxygen is O2, so it's 2 oxygen atoms. So what I've decided to do is oxygen is red and hydrogen is blue, which you're likely to find in a textbook, but let's get rid of those things. And H2O is something like this. So you've got 1 oxygen and 2 hydrogens. So it's important to know if you don't have a subscript after the atom, there's one of those. And if you do, well, you have however many. Now the idea is you want to balance out the number of atoms before and after the reaction. So you've got the reactants here and the product over here. So I want exactly the same. Now straight away I can see I've got 2 hydrogens here, 2 hydrogens here. That's brilliant. 2 oxygens here and only 1 oxygen over here. Now what I can't do is say, well, I'll put an oxygen here. This is all balanced now, because this isn't the equation. My equation deals with H2O. So if I'm going to increase the amount of water, or if I'm going to increase the amount of oxygen, I need to do it like this. So now I've got 2 oxygens, which balances out this. But now what I've got is 4 hydrogens. I've only got 2 here. So what I do is I put another one of those hydrogen molecules over here. And now I've got 4 hydrogens here, 4 on the product side, 2 oxygens on the reactant side, 2 oxygens on the reactant side, and it's all balanced. However, just doing this isn't going to get you any marks. We actually have to put in the coefficients. So what that is, I've got 2 of these, that's a 2. I've only got 1 of this, so I can just leave it. That's fine. And I've got 2 of these waters, so I put 2, and that's how you get the mark. You get the mark for this part over here. Not any of these drawings, as cool as they may look, you get the mark for the correct coefficient. Okay, let's look at another way how to work this out without doing all of those drawings, because drawings takes a long time. So now we have to come up with a table, and my table says atoms, I've got before, and I've got after. Okay, and it's talking about before the arrow for the reactant side and after the arrow for the product side. So the atoms we have are hydrogen and oxygen. Before we've got 2 because H2. After we've also got 2 because of H2. Before for oxygen we have 2, and after for oxygen we have just the 1. So what I'm going to do is I'm going to increase the amount of this. Now the reason why I do this is because this is going to make that into a 2, balancing out the oxygens. However, it does mess up this, make it into a 4. So what do? Well, I need something times 2 to give me 4, and that's going to be a 2. So now it's balanced, okay? So 4 before and after for hydrogen, 2 before and after for oxygen. 2H2 plus O2 gives you 2H2O. So that's the other way how to figure it out. Now it's all down to practice, so the best way to get good at this is to practice it a little bit more. Let's have a look at another example. Here we have C plus S8 gives you CS2. So let's figure this out. First of all, C is carbon, so that's going to be represented by this little black circle. S8 is sulfur, but it comes in a ring with 8 atoms attached to it, kind of a little bit like that. By the way, if you're going to do the drawing group, you don't have to be accurate. You can draw it however you like, as long as it has the right amount of atoms. That's all that counts. And on the product side, we've got CS2, which is a little bit like this. Now, how do we balance this out? Well, first up, I've got way more sulfurs than I have of this. So because we've only got 2, we multiply that by 4. 1, 2, 1, 2, 3, 4, like that. Now I've got the right amount of sulfur on the product side, okay? However, I'm in balance with the carbon, and it's very simple. All I've got to do is not C5 or anything like that. They're single atoms, so I can just add like this. Now, again, it's not completed until I put the coefficients. We've got 4 carbons, so we put 4 over here. S8, there's only 1 of those. We don't need to worry about that. And there's 4 CS2. We can put a 4 like this. Dead easy. I'll show you the other way of how to do this now. So first of all, what we do is we have our little table. So it's atoms before and after, like this. And we've only got C and S. C is 1 before, 1 after, nice and easy. S is 8 before and only 2 after. So how do I make this 2 into 8? Well, I've got to multiply it by 4. So I have to put a 4 here. This is my coefficient. I can't just put CS8. That would be a completely different molecule. So that would change this to an 8, but it also changes this one to a 4 because I've got 4 times. This is basically saying 4 times CS2, okay? So I've got 4 carbons. So to balance that out, I put 4 over here. Voila, balanced, okay? Same number of carbons on the reactant side as the product side. Same number of sulfur before the arrow and after the arrow. Nice and easy. Let's have a look at another example. Okay, so now we have N2 plus H2 gives you NH3. So first of all, the picture method. N2, I'm going to have represented with these green atoms. That's 2 nitrogens stuck together, okay? H2 is going to be like this, 2 hydrogens stuck together. And NH3 is going to look a little bit like this. So 1 nitrogen and 3 hydrogens. So let's have a look. Here and here, you can see that we've got 2 hydrogens before and 3 after, so that's not balanced. And we've got 2 nitrogens over here, only 1 over there, so the whole thing is unbalanced. So what am I going to do? Well, first of all, the easiest thing to do is get the right amount of nitrogens either side. And the best way to do that is just to put another one of these over here, okay? That way that we've got the right amount of nitrogen after and before, but that does leave us with 1, 2, 3, 4, 5, 6 hydrogens after and only 2 before. So what are we gonna do? Well, we just do like this. Add the hydrogens over here. And now everything looks balanced. Hydrogen 6 before and hydrogen 6 after. Nitrogens is 2 before and 2 after. Perfectly balanced. However, like I said, this does not get you the mark. What gets you the mark are the coefficients. I don't need to put a number here because I've only got 1 molecule of N2. I've got 3 molecules, 1, 2, 3 of H2, and I've got 2 molecules of NH3. That will get you your mark. So N2 plus 3H2 gives you 2 NH3. I'll show you the other method. Okay, so let's do our table. We have atoms, we have before, and we have after. And our atoms are nitrogen and hydrogen, okay? 2 of those nitrogens here before. We got 1 after. Hydrogen, we got 2 before and 3 after. Okay, now we've got two points of attack. We could either increase the nitrogen, which is what I want to do, because that way I can make that directly into a 2, or I can find the lowest common multiple of 2 and 3 and attack it that way. Either way, you're going to get the same result. I always like to be a bit simple, and I put the 2 there That's going to be nice and easy, but it does make this into a 6. 2 times 3 is 6. That's why that one's a 6. Okay? Which means I need to make that 2 into a 6. So something times 2 gives you 6. It's going to be 3. It's balanced. Okay, so we've got N2 plus O2 gives you N2O5. So let's get the drawings out. It's probably the easiest way to do it. So N2 is going to be represented with that. 2 nitrogens stuck together. This one is going to be O2, 2 oxygens stuck together. And N2O5 is going to look a little bit like this. Now, immediately you can see the nitrogen is fine, but the oxygen isn't. Now, the trick here is to find the lowest common multiple of 2 and 5. Now, in case you don't know how to do lowest common multiples, it's a little bit like this. You write out all of the multiples of 2, 2, 4, 6, 8, 10, 12, 14, like that. You could go on, but there's no need. And you can write the multiples of 5. So 5, 10, 15, 20, etc., etc., etc. You don't need to continue for too long because we're trying to find the lowest common multiple. So the lowest multiple that they both have in common would be 10. So I'm going to try and get that into 10 and this into 10. So my oxygens would then be equal to 10. So the way to do that is I just add one more of these. So now I've got 2 N2O5, which means I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygens, which means I need 10 oxygens over here. We need one more. It's going to interfere with the old maths over here. I'll just leave it there. Put this one over here. That's 5 things. 5 times 2 is 10. And let's see, 1, 2, 3, 4. Well, I've only got 2 there, which means I need this over there. Now it's all balanced. However, I don't get any marks until I put in the coefficients. And the coefficients is going to be 1, 2 of those. 1, 2, 3, 4, 5 of these. And 1, 2 of those. Nice and easy. So let's just write out our table. So atoms before and after. We've got nitrogen, we've got oxygen. 2 nitrogens before, 2 after. 2 oxygens before, 5 after. Okay, so what I'm going to try and do is get my lowest common multiple, which is 10 for both of them. So I'm going to get that oxygen into 10 by putting a 2 in front of all of this. So you end up with 10 over here, but you also end up with 2 times 2, which is 4 of those nitrogens, okay? Which means these 2 things need to get balanced as well. I'll do the oxygen first. Something times 2 gives 10. It's going to be 5. So now the oxygen is balanced, but the nitrogen isn't until I put a 2 here. Voila, it's balanced. It's as easy as that. It takes a little bit of practice, but once you get used to it, you can bash through them fairly quick. Thank you very much for watching, and goodbye.